Next question, thank you very much, and your question is?
Thank you. First of all, thank you from all of us and everyone who enjoys this wonderful opportunity, Brian.
Oh, thank you. I was just saying, thank you. I was just saying earlier to Robin, actually, the show is structured so that the first half there's quite a lot of information. It's really setting up. So I saw some people tweeting, "My mind is blown." Your mind's really going to get blown when I answer the why, which I will do. I do know the answer to why, or at least, well, know the answer to why. That's not what science is all about, knowing things absolutely. I will propose a possible theory for the answer to why, which could be disproved by evidence in future.
Brian, you spoke about in consideration of motions of clusters of galaxies, and certainly in looking at the velocity light curves, which is not what you spoke about, but excuse me, of stars in our own galaxy with the large radial distance from the centre. We use Newtonian mechanics, and isn't this like losing something in a dark street and going to look on the freeway because you can see it better? Because I'm wondering, there's so much in GR that I'm just wondering, is it reasonable to suspect that there may be answers in interference of waves or chaotic effects with masses rotating?
Yeah.
And that I know the dark matter and dark energy models the Big Bang extremely well, and I know that there's lots of support, but is there something? Yeah.
It's a good question. So the question is, I mentioned it. I'm not really talking about dark matter very much. I've mentioned dark energy. I will show actually a graph. I had one equation and one graph that I was allowed by the director. So I've done the equation. I've got two graphs. Sorry. It's like a Python sketch, isn't it? Amongst many graphs. But I will show a graph that shows how sensitive some of our observations are to the amount of dark matter and dark energy in the universe. But the question really is referring to that there is an active area of research that says, well, okay, so it looks like about 95% of the universe is missing in a sense. It's the dark matter and the dark energy. As I've said, that's a very special number, this so-called critical density. We'll talk about that later. But people do look at seeing, well, is it actually our understanding of gravity itself that's at fault? So could it be that you can add something to Einstein's equations of general relativity that modify the way that the force operates at large distances in order to trick us into thinking that there's dark energy and dark matter? And people do that, and so very good theoretical physicists. What I would say is it's very difficult, because general relativity is so precise and it's been tested so precisely in so many different conditions that the way that you have to modify it is extremely restricted. What you tend to find is that when you add some bits in, which might describe the way that the galaxies interact with each other and these things that Fritz Zwicky saw back in the 1930s, you break some other prediction that the theory makes. So the only thing I could say about that is that people try that, it's a very good idea, but no one's been able to do it in a consistent way. And then I'll show a little bit later on, this idea that there's something else out there, the dark matter and the dark energy, comes from independent measurements, and I'll show you another one in about 4 or 5 minutes or so. I should say with the questions, I hope, Robin is wandering around just standing in the same place. What I really wanted was for me to do it, so I could go over there, and then go over there.
And then I'll run the long way back to the stage if that's what you want.
Because he's always been, he moans about, I look so old and Brian looks so young. It's because you don't do any exercise, Robin. Run around. Anyway.
Right, so we have another young scientist. His name is Dan. Dan, what is your question?
If matter